Hello, this is Mr. Montgomery. This video is for my Physical Science 2 students about dating geologic events. Two purposes for this video. One, to show you the procedure that you're going to be doing yourself at home. Two, because you're also going to use the data that I collect while I'm demonstrating this procedure for you as part of your lab handout. All right, so let me show you what we're using and how this is going to work. So here are my materials. One, you got your lab handout. There will be a link to this in Canvas for my students. I'll put a link also down in the description for this lab. But you're going to be collecting data right here, using that data to produce some graphs, answering some questions, and then there's a third part here we'll come back and talk about later as well. All right, but materials, just got plastic cup right here, a plate. I have M&Ms for my 100 objects that I've counted out. Whatever your objects are, you just want to make sure they have a distinct, two distinct sides. That on an M&M clearly have M on one side, blank on the other side. Coins work with heads and tails. Skittles would work. Checkers would work. These are the Valentine edition M&Ms. I just separated out red and white ones. The pink ones were kind of hard to see the M clearly on that side, just easily on camera at least. All right, but basically what we're going to be doing, taking these 100 M&Ms, putting them inside our cup, shaking them around. Shaking them around is going to represent our half-life. We're going to dump them all out right here. And what we're looking for is any one that stays with the M side up is going to be considered that it didn't go through radioactive decay, that it's still radioactive. Any one that came out of the cup with the blank side up is going to have decayed and turned into a daughter product. So we will separate those, the M's from the non-M's, or the heads from the tails, whichever way you end up doing it. Count each one, and then the ones that are undecayed will go back into the cup to repeat the whole process again. So I didn't shake these up this first time, so that one didn't count. And I'll probably do some, fast forward montages here as we get into, counting these things. All right, so I'm going to shake this up for roughly, 10 seconds. Plate. Throw that one in the plate as well. All right, and so now I need to come in here and separate the parents from the daughters. So the parents, again, the one that M still shows. So what I'm going to do is I'm going to count those as I drop them into my cup over here. And 40, 44, let me check this one right here. Yeah. All right, so I now have, after the first half-life, 44 that are still radioactive, and so that means I must have 56 that are not radioactive any longer. So I'm going to take these 56, put them back in my bag. We are done with those, but you'll record that data as the very first half-life. Okay, so that's going to go, let me get the page here. Okay, if when you're doing yours, you would record it as 44 unchanged, 56 that were. All right, when you're recording my data, all you're going to need right now for my instructor data right here would just be that I had 44 that were unchanged, and then whatever that number is going to be on the next few half-lives here. All right, so shake again. All right, so same thing, here they are. And I'm gonna, again, count out the ones that have the M's facing up. 23 that time. All right, I got 23 left. So again, put those daughters in the bag with the rest of them. All right, so that was half-life number 2. We had 23 remaining. All right. Pour those out. All right, so this is now half-life number 3. Okay, show you what we got here. All right, so again, counting out the M sides up. There's 4, 5, 6, 7. Only 7 of them that time. All right, so these reactive ones, daughter products going back in there. All right, so I had 7 left after 3 half-lives. Feel like I'm playing Yahtzee. Okay, all right, so now only 2 this time. Only 2. This is not very mathematically accurate here, but it's all probability. And now we have 1 remaining. All right, so just 1 left. Out. And 0. All right, so for the rest of mine then, the rest of my data, you would just fill in zeros for the remainder of these. Okay, for yours, again, you're going through your 9 half-lives, recording how many you had each time, how many daughters were produced. So these 2 numbers, they should always add up to equal 100 because there's still a total of 100 atoms involved here. All right, but again, once you get down, if you have 1 or 2, whatever left over after 9 half-lives, you can still stop after 9. But if you run out after 7, then just fill in the rest with zeros and 100s over here. All right, you're going to then report this information into the discussion module inside of Canvas for my students. So you'll now have your own data. You'll have my data from this video that you're watching right now. And then from the discussion board, once everybody has time to get their submissions, then you can come in and get data from 6 of your classmates and then average out all 8 of those. Mine, yours, your 6 classmates, average those all out. Once you get that average, you're going to plot on this graph right here. Okay, the graph that's on here now would be a perfect if every time you lost half, you went from 100 to 50 to 25 to 12.5 to 6.25 and so on and so forth over here. You're going to plot your own data, just your numbers that you got yourself, and you're going to plot the class average after you've averaged up the 8 of them. Label those 2 lines so we can tell which one is which. Put a title on your graph over here as well. All right, answer some questions. All right, and then part 3. In part 3, you're given these columns that represent taking rock samples from different locations. And at those different locations, you're finding different types of rocks that are represented here. And by comparing each of these different locations, you're asked to figure out what are the oldest rocks, what are the youngest rocks. So list them in order from oldest to youngest. Well, an older rock is always going to be underneath a younger rock. But with 8 different types of rocks, you see each location only included 5 of those. So some places there were missing information in the rock layers. That's what these little zigzag lines right here represent. They represent an unconformity where something, maybe a flood, something has erased, or erosion I should say, has erased a rock layer. And so you're going through here and working your way. I work my way from bottom to top, from oldest to youngest, figuring out what's the oldest possible rock, what's the youngest possible rock. Keeping in mind, an older rock can never be under, an older rock must be under a younger rock. The younger rock can never get underneath the older rock there itself. All right, so that's going to do it for this lab experiment. I hope it all made sense. As always, if you need more help, feel free to reach out to me, and y'all have a great day.